Hello everyone and welcome. In this lesson we're going to be finding the rate of change of a function at a point. Now how do we do this? Well, that's actually kind of a trick question, but it ends up being so important in calculus that we're going to spend quite a bit of time on it. Why is it a trick question? Well, because at a point nothing is really changing. If I have two graphs and I were to pick any point on the graph, I'm not going up, I'm not going down, I'm just sort of stationary. So what can we do? Well, it may help to think of this problem in a different way. What if you were to take a picture of someone running? We know this woman is moving, but we can't see it in our picture. The same can be said for our point. Imagine we've taken a picture of it, and then we need to figure out how fast it's moving. So we can approximate the rate of change at a single point by calculating the rate of change over smaller and smaller intervals that get closer and closer to the point. Huh? Well, we choose a second point and determine the rate of change between those 2 points. So for instance, here I have a second point, and I'm going to move that point closer and closer and closer, finding the rate of change again and again and again until we get closer and closer, as close as we can to that point. And hopefully we're going to see a pattern in our calculations that makes us feel confident enough to approximate the rate of change at that point. For example, let's determine the rate of change of this function at 2, 1. We're going to start further from that point at 0, 2, move to 1, 2, 1.5, 2, 1 3/4, 2. We're getting closer and closer and closer. And we're going to find the rate of change. So I'm going to plug in my values for 2 and 0 into my function to get an output of 1 and -3, see how far away those are, and then divide that by how far away my inputs are, 2 and 0, and I get 2. Now I move my point further to the right, I find my rate of change, and I get a rate of change of 3. I do it again, closer, I get a rate of change of 3.5. I do it again, I get a rate of change of 3.75. And I repeat, the point keeps getting closer and closer and closer, 1.9, 1.99, 1.999. I can never actually reach 2. I need to have an interval. I need to have a start and an end. But 3.9, 3.99, 3.999, I think we've seen enough of a pattern. The rate of change at 2, 1 is 4 because we're getting closer and closer to 4 as our interval gets smaller and smaller and works its way down to the point we're interested in, 2, 1. Example 2, let's determine the rate of change of this point instead. So we're going to start a little bit away at -1.1, move a little bit closer to -1.01, and move a little bit closer to -1.001. And I see that my slope is going to be -2.1, -2.01, -2.001, so I'm getting closer and closer to -2. Therefore, the rate of change at this point is -2. Thank you. I hope this video is helpful and that you visit us again.